Hi everyone, this is Big Face from Big Face Robotics. I'm back with a new project. Over the years I've accumulated quite a few parts and I want to start a new project and turn these into some sort of robot, or more likely to start with some sort of remote control wheeled car, which I can then look to turn into a robot and automate some features at a later date. So I raided my parts bin and I've got Arduino, an Arduino Mega, an Arduino Nano. I've got some of these cool joystick things, I've got a couple of them. I've got some L298 based motor drivers, a few little miniature bearings. I've got some bigger ones as well, possibly. I've got some round stock for drive shafts, some Bluetooth modules, some drive belts. I've got wheels from previous projects I can use, and I've got a whole box full of these motors here, 12 to 24 volt DC brushed motors, which I've used in the past, and they're just sat in a box, so might want to try and do something with them. I've got an array of batteries as well. I've used these motors before and run them on 12 volts or less. For this project I've got some lead acid batteries which I've acquired, which I'm joined together, give 24 volts. These are pretty strong motors at 24 volts, so that should be good fun. I've got some casters and sort of things I've used in other projects that I can use again, or I might make something else. I wouldn't mind getting some different wheels, maybe some with pneumatic tyres might be quite nice, so I can use this thing outside. And I'm going to try and put all this together bit by bit, and I'll show you what I'm doing as I do it. So the first thing to do is to try and get some sort of drive arrangement happening. I've used this before, some aluminium sort of box section which I can throw up on the milling machine and shape how I want. I've test printed a few pulleys as well, 3D printed pulleys. Not sure how they're going to work with the GT2 belts. I might have to swap this out for a bigger, thicker, stronger belt at some point, but I'm going to go with this for now. So I've done a few little experiments. I've also 3D printed some housings for the bearings, so these can bolt onto the side of some of this box section and support the axle for the wheel. So to kick this off, I went on to FreeCAD and did a 3D design, as you can see, using the aluminium box section with some 3D printed parts to form a drive assembly. So it'll be a belt driven wheel, driven from the motor, running at 24 volts. So I'm going to get started with making that, 3D print some more bits, and I'll show you how that looks when it's done. Well, I've got as far as mounting the motor, the two pulleys and the drive belt. I'm having a bit of trouble getting the belt tensioned up. I could do with some sort of tensioning device, and it's working. It's quick. The wheel is spinning very fast. The only trouble with the belt and pulley arrangement is the amount of tension that's being put on this on the front of this motor, and you can hear that from the noise It's quite noisy compared to when it's not loaded up. Okay, so today's a new day. I've learned quite a bit from the previous test that we did. I really like the design of the bearing housings. I like using the aluminium sort of rectangular section that we're using. Some of the 3D prints came out really nicely. This little base plate for mounting the motor underneath, for example, really nice. The main problem is that the pulleys, the 3D printed pulleys, maybe the way they're being printed, the teeth aren't deep enough, and therefore the belt's slipping a bit. And when I'm trying to get tension on the belt, it's putting quite a lot of strain on the front end of this motor, and I don't think it would last long running like that. So I've got two options, I think. I can either buy some aluminium pulleys and design a tensioning device for the motor to get that belt nice and tight and keep the motor square, or what I'm actually going to do, which is move over to using gears instead. With 24 volts running through one of these, the motor's spinning very quickly, so I want to reduce the speed and up the torque a little bit. And with the batteries and all the other weight that the robot's going to be carrying, I want to use these bearing blocks to take that load, so I need to gear it somehow. So in CAD I've redone the design and allowed for some gears, and actually it makes a much more compact unit, as you can see. The gear ratio is about 2.5 to 1, something like that, so it should reduce the speed and up the torque as required. I've also left a little space there because at some point I might want to put an encoder on these, but the goal for now is just to get the drive assembly working, hook up an Arduino to a motor controller and start controlling the motor. Okay, so I've printed out the hub to attach the wheel, and a little cover for the front with a nice logo on it. So if I connect this up and test it out, just hooking the wire straight up to the battery for a minute. As you can see, it's working. So if I apply a bit of torque to the motor, or to the wheel rather, the motor will skip. I just pulled the wire out, so that was why that stopped. But actually the motor on the bracket is quite wobbly. I'm going to have to make another little bracket to sit in underneath to take out some of that play in the motor bracket. So that'll be the next job. Right, so that's my solution to the motor problem. It's a 3D printed band that sits around the motor at the non-drive end, and that is not moving anywhere. That's now very rigid. So if we fire it up again, I'll try and stop the wheel with my hand. It's not moving and the gears are staying engaged. So I probably like the wheel going a bit slower. It doesn't need to be that quick, I don't think. But I'm a bit limited to what gear reduction I can do in just one pair of gears, because otherwise this large gear is going to be too big. So it is what it is. I'm quite pleased with it. It's very sturdy. I think the robot's going to be able to carry quite a bit of weight. I've got these two big batteries to mount on there somewhere. So the next job's going to be to wire up an Arduino with a motor controller and have some variable speed on this, and we'll see what the torque's like at lower speeds, and whether I forge on with this design or try something different. Come back soon and hopefully have some electronics hooked up to this. Hit the subscribe button if you like my videos, and I'll see you next time. Thanks for watching.